Dear friends, let us go through an important and interesting concept of functions in C programming language, which is essential to make use of modular programming technique. What is modular programming? In modular programming, the problem is subdivided into number of sub-problems or modules. It is clear that the effective problem solving must do problem decomposition. Breaking a problem into small manageable pieces is critical in writing large programs. In C language, a self-contained block of code that performs a particular task is called a function. C supports the use of various library functions, which are used to carry out a number of commonly used operations or calculations. C also allows programmers to define their own functions or carrying out various individual tasks. Now, let us briefly discuss about the modular approach in programming. Modular programming approach. The use of user defined functions allows a large program to be broken down into a number of smaller self contained components, each of which has some unique identifiable purpose. Thus, a C program can be modularized through the intelligent use of such functions. There are several advantages to this modular approach to program development. For example, many programs require a particular group of instructions to be accessed repeatedly from several different places within a program. The repeated instruction can be placed within a single function, which can then be accessed whenever it is needed. Moreover, a different set of data can be transferred to the function each time it is accessed. Thus, the use of a function avoids the redundancy in instructions. The decomposition of a program into individual program modules is generally considered to be an important part of good programming. Types of functions. A C program is made up of one or more functions. Based on the nature of creation, functions can be classified into built-in functions and user-defined functions. Built-in functions are predefined and supplied with the compiler. These are also called library functions, and all these functions are available in C library. The functions defined by the users are called as user-defined functions. So far, you might have used only one user defined function called main. Let us now consider an example. Hash include math.h and hash include stdio.h. Then we start main in curly braces float xy scanf percentage f ampersand sign x, then y is equal to sqrt x, printf square root of percentage f is percentage f xy curly brace close. The main function invokes or calls other functions within it. Here, three functions scanf, sqrt and printf are invoked by the main function. The function main is the calling function and the other functions scanf, sqrt and printf are called functions. A function that invokes another function is known as calling function. A function which is invoked by another function is known as a called function. In C, main is the first calling function in any program. It is a special function which tells the compiler to start the execution of a C program from the beginning of the function main. It is not possible to have more than one main function because the compiler will not know where to start execution in such a situation. An identifier other than keywords followed by an open parenthesis is recognized as a function name by the compiler. The items within the parenthesis are called as parameters or arguments through which information is passed to the function. A function may be used to calculate and return that value to the calling function. The information is returned from functions by return statement. Once the function has been executed, control will be returned to the point from which the function was accessed. It is not necessary that every function must return information. There are some functions which do not return any information. For example, the system defined function printf. To make use of the user defined functions, you must be able to define a function, declare the prototype of a function and invoke the function. Function definition. Function is a self-contained program segment that carries out some specific well-defined task. The definitions of function may appear in any order in a program file because they are independent of one another. A function can be executed from anywhere within a program. Before using any function, it must be defined in the program. A function definition describes what a function does, how its actions are achieved and how it is used. It consists of a function header and a function body. The general format for defining a function is return type, function name, in parenthesis parameter list. This is called function header. Within curly braces, declarations, statements, this is called function body, and a return expression, and curly braces close. The first line of a function definition contains the data type of the information returned by the function, followed by function name and a set of arguments or parameters separated by commas and enclosed in parentheses. As it heads the function, it is known as function header. The set of arguments may be skipped over. The data type can be omitted if the function returns an integer or a character. An empty pair of parentheses must follow the function name if the function definition does not include any argument or parameters. The general form of the function header is data type, function name within bracket, formal argument 1, formal argument 2, etc., formal argument n. For example, int swap within bracket int a, int b. Some points to be kept in mind while specifying return type. Return type specifies the data type of the value returned by the function. Return value may be of any data type other than array and function types. If return type is omitted, the value returned is assumed to be an integer type by default. Void is specified in the place of return type if the function returns no value. Function name. Function name is an identifier. It cannot begin with underscore because such names are reserved for the use of C library. It can contain up to 31 characters, but it is wise to have a maximum of 6 characters to distinguish different function names by a linker. The formal arguments allow information to be transferred from the calling portion of the program to the function. They are also known as parameters or formal parameters. The arguments are called actual parameters when they are using in function reference or function call. The names of actual parameters and formal parameters may be either same or different, but the data type should be same. All formal arguments must be declared after the definition of function. The function body follows the function header and it is always enclosed in braces. The body of the function is composed of declarations and statements. The statements describe the action to be performed by the functions. Information is returned from the function to the calling portion of the program by the return statement. The return statement also causes control to be returned to the point from which the function was accessed. In general, the return statement is written as return expression semicolon. The value of the expression is returned to the calling portion of the program. The return statement can be written without expression. Without the expression, return statement simply causes control to revert back to the calling portion of the program without any information transfer. The point to be noted that only one expression can be included in the return statement. Thus, a function can return only one value to the calling portion of the program by return. It is not necessary to include a return statement altogether in a program. If a function reaches the end of the block without encountering a return statement, control simply revert back to the calling portion of the program without returning any information. There are some points that must be kept in mind while defining a function. A function cannot be defined more than once in a program. One function cannot be defined within another function definition. Function definition may appear in any order. If a program uses several functions, the functions can be distributed in many files, but a function definition cannot be distributed in more than one file by splitting the same definition. Usually, the function name is given as the file name when several files are used to write a complete program. Function declaration. Whenever a function is invoked in another function, it must be declared before use. Such a declaration is known as function declaration or function prototype. Function declaration always end with semicolon. The general format is return type, function name, within brackets parameter list, semicolon. In function declaration, parameter names in the parameter list are optional. Hence, it is possible to have the data type of each parameter without mentioning the parameter name. Return type, function name, within brackets data type 1, data type 2, etc., data type n, semicolon. This declaration helps the compiler in detecting inconsistent type of function calls and mismatching types of parameters used. If the value returned by a function is int type, the declaration of function is optional. For all the other type of functions, declaration is mandatory. The return type is void when the function returns no value. Function prototypes are desirable because they further facilitate error checking between the calls to a function and the corresponding function definition. Let us examine examples of some function prototypes. Int example within brackets int or int example int a int b within brackets semicolon. Next one, void example within brackets void. Another one, void fun within brackets char long or void fun within brackets char c long f. The names of the arguments within the function declaration need not be declared elsewhere in the program, since these are dummy argument names recognized only within the declaration. Observe in the table that the function declaration is different from the function definition. In function definition, there is no semicolon at the end of the closing parenthesis of the parameter list. In function declaration, there is a semicolon at the end of the closing parenthesis of the parameter list. In function definition, the function body follows it. In function declaration, the function body does not follow it. Function definition is mandatory for all functions, but function declaration is optional for function returning int value. Function call. A function can be accessed by specifying its name followed by a list of parameters or arguments enclosed in parentheses and separated by commas. If the function call does not require any arguments, an empty pair of parentheses must follow the function's name. The general format of a function call is function name within bracket e1, e2, etc., en, where e1, e2, en are argument expressions named as actual arguments or actual parameters. If a function returns a value, the function call may appear in any C expression and the return value is used as an operand in the evaluation of the expression. Let us now consider an example of function without returning any information for more clarity. In this program, within main, int main, we are declaring a function int maxin within braces int in and reading two integer values x and y and a call to function maxin xy return 0. Then a function definition maxin int x into y within the body int z, z is equal to x greater than or equal to y question mark x colon y, then print the maximum value z return. This maxin function do not return any value to the calling program. It simply returns the control to the calling programs. So, if it is even not present, then also program will work efficiently. Most C compilers permit the keyword void to appear as a type specifiers when defining a function that does not return anything. So, the function definition will look like this if void is added to it, void max I int int. Let us consider another example of function. In this program, within main declaring 3 integers a, b, c and reading 2 values a and b, then c is equal to sum v within braces a, b. Then we come to the function definition sum v int a int b within braces declaring another variable d, d is equal to a plus b and return d. This program returns the sum of 2 variables a and b to the calling program from where sum v is executing. The sum is present in the variable c through the return d statement. There may be several different calls to the same function from various places within a program. The actual parameters may differ from one function call to another. Within each function call, the actual arguments must correspond to the formal arguments in the function definition. That is, the number of actual arguments must be same as the number of formal arguments, and each actual argument must be of the same data type as its corresponding formal argument. Passing argument to a function. Arguments can be passed to a function by 2 methods. They are called passing by value and passing by reference or address. Pass by value or call by value. When a single value is passed to a function by an actual argument, the value of the actual argument is copied into the function. Therefore, the value of the corresponding formal argument can be altered within the function, but the value of the actual argument within the calling routine will not change. This procedure for passing the value of an argument to a function is known as passing by value. Let us consider an example for better understanding. Within this program, within main, we declare a variable x equal to 3 and print x from main before calling the function, and we call the function change x, then again print the variable x from main after calling the function. In function change, we declare an actual argument int x, then changing the value of x, then x is equal to x plus 3, then printing the value of x from function after being modified, then return. The original value of x, that is x is equal to 3, is displayed when main begins execution. This value is then passed to the function change, where it is sum up by 3 and the new value is displayed. This new value is altered value of the formal argument that is displayed within the function. Finally, the value of x within the main is again displayed after control is transferred back to the main from change. The final output of the program will be x is equal to 3 from main before calling the function, x is equal to 6 from the function change after being modified, and x is equal to 3 from main after calling the function change. Passing an argument by value allows a single valued actual argument to be written as an expression rather than being restricted to a single variable, but it prevents information from being transferred back to the calling portion of the program by arguments. Thus, passing by value is restricted to a one-way transfer of information, passing by reference or call by address. When an address of variable is passed to a function by actual argument, the address of the actual argument is transferred to the function, where it is received in a pointer variable. A pointer variable holds the address of another variable. Therefore, the value of corresponding formal argument can be altered within the function. The effect of this will be reflected in the actual argument within the calling routine. This procedure of passing the address of an argument to a function is known as passing by address. Let us consider an example which explains pass by reference method. In this program, within main, we declare an integer variable x is equal to 3 and printing the variable x from main before calling the function. Then we call the function change by passing the address of x to the function, then printing again the value of x from main after calling the function, and within the function change we receive the address of x in star x, it is a pointer variable, then altering the value of x using the pointers star x is equal to star x plus 3 and printing the x from the function after being modified, then return. The original value of x, that is x is equal to 3, is displayed when main begins execution. The address of the variable x is then passed to the function change, where it is sum up by 3 and the new value displayed. This new value is the altered value of the formal argument that is displayed within the function. Finally, the value of x within main is again displayed after control is transferred back to the main from change. The final output of the program will be x is equal to 3 from main before calling the function change, x is equal to 6 from the function change after being modified, and x is equal to 6 from main after calling the function change. Arrays are passed to the function differently than single valued entities. If an array name is specified as an actual argument, the individual array elements are not copied to the function. Instead, the location of the array is passed to the function. If an element of the array is accessed within the function, the access will refer to the location of that array element relative to the location of the first element. Thus, any alternation to the array element within the function will carry over to the calling routine. Recursive function calls. Based on the function call, functions can be classified as recursive and non-recursive functions. If a function call itself in the function body of its function definition, it is known as a direct recursive call. If a function calls another function which in turn calls the first function, then it is called as an indirect recursive call. In either case, the definition of function results in a circular chain of calls of the same function. Hence, the execution will continue indefinitely. To terminate this indefinite execution, a statement without recursive call must be executed. Therefore, every recursive function must have a proper terminating condition to provide a non-recursive exit. The process by which function call itself repeatedly until some specified condition has been satisfied is known as recursion. The process is used for repetitive computations in which each action is stated in terms of a previous result. In order to solve a problem recursively, two conditions must be satisfied. The problem must be written in a recursive form and the problem statement must include a stopping condition. The best example of recursion is calculation of factorial of an integer quantity, in which the same procedure is repeating itself. Let us consider the example of computing factorial using recursion. In this program, after the main function, we have another function fact. The point to be noted here is that the function fact calls itself recursively with an actual argument n minus 1 that decreases in value for each successive call. The recursive call terminate the value of the actual argument becomes equal to 1 within the if else conditional statement. When a recursive program is executed, the recursive function calls are not executed immediately. Instead of it, they are placed on a stack until the condition that terminates the recursion is encountered. The function calls are then executed in reverse order as they are popped off the stack.